And good morning, good afternoon, or good evening, depending on where you are in the world today. And welcome to today's TechStrong Learning Experience brought to you by AWS and Kubecost. My name is Jared Harris, and I'll be your host for today's workshop. But before we get started, I do have a few housekeeping notes. This workshop is being recorded, so if you miss any of our discussion or would like to share with a friend, the on-demand version is being recorded and will be made available to you shortly after the workshop concludes. If you have any questions, please use the question tab on the right side of your screen. There's also a chat tab where we want you to engage with the speakers. You can engage with other audience members, share your thoughts, or just tell us where you're signing in from as well. You can also click the link at the top of your chat box to get started with your free AWS account if you haven't done so already. Finally, at the conclusion of today's workshop, I'll be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of the program. Let's go ahead and kick off today's workshop, Managing and Optimizing Kubernetes Cost with Kubecost and Amazon EKS. Today, our speakers are Lynn Lam, Solutions Architect at Kubecost, Mike McDonald, Partner Solutions Architect at AWS, and Chris Reynolds, Chief Architect of Public Sector at Kubecost. At this time, it's my pleasure to turn the program over to you, Lynn. Go ahead and take it away, and I'll turn my camera and microphone off.
Thank you, Jared, and welcome everyone to our workshop today. And today we would like to, we are excited to introduce you our collaboration between Kubecost and AWS. And in this workshop, you will learn how to install Kubecost and use Kubecost with your Amazon EKS cluster. Mike, I would like to hand it off to you so you can help the attendees to prepare the environment, and then I can take it from there.
Sounds great. All right. If everyone will hang on for just a moment, I'm going to share my screen real quick. So in the chat, we have 2 links. Either one of those will work to get you your access to your free AWS account for the session. We've set these AWS accounts up for you to use as we run through the content, so you're not going to incur any sort of bill, and so that you don't have to wait around for a Kubernetes cluster to deploy as a part of this. So the first thing that you're going to see after you click that link is going to be an option for how to sign in, and you're going to want to pick the one-time password button this time around. So you're going to have a few options for how you can learn today. Feel free to do whatever works best for you. First option you have is to follow along live with this account, getting hands-on with the commands that we're going to be running and really kind of diving in that way. I know some people would rather watch the workshop first and then try it on their own later, in which case feel free to save that account access link or go ahead and log in and set up an account, the account now. And then later you can go in with that workshop content kind of link and run through it on your own. Then finally, if you'd prefer, there's no need to grab an account. You can just sit back and enjoy the walkthrough we'll be doing. As far as these accounts go, you will have access to them for the next about 48 hours. So, no rush in running through the content. And if you do want to run through it multiple times, there's some cleanup for the workshop at the back of the instruction set. So you can kind of go through and do this again if you'd like. So after you click the email one-time password link, you're going to be prompted to fill in your email address. Make sure that this is one that you have access to right now, because we're going to be grabbing that emailed password in just a moment. After you submit the email, it's going to ask us for that passcode on the next screen. So you'll be able to, or you'll need to check that email to grab that passcode and fill that in to submit. Just so that I can get an idea of where folks are at, can you put, we've got these little emojis at the bottom of the chat. Can we go ahead and do the heart emoji or put a +1 in the chat when you've reached the review and join screen after the passcode kind of has been emailed to you and you've submitted that? Got the first heart, first +1, perfect. And then we do have those 2 links there because one of them I can only put so many accounts on. So if one of the links doesn't work for you, go ahead and try that other one. They'll both set you up with the same account, same type of Kubernetes cluster, existing infrastructure. So either one of those will work. Real quick before I move on here, do we have anybody that hasn't been able to kind of gain access to that or is having any sort of error? Feel free to request help in the chat there, and we'll try and get that figured out. All right. So I'm going to go ahead and move on here. The next screen that you're going to see is with some terms and conditions. For my account access, it kind of moves me straight through to this. So I didn't have the email one-time password piece, but now you should be on this review and join screen. Feel free to review these terms and conditions, but basically what this is going to be asking is, requesting that you please don't use these accounts for anything outside of the content that we're going to be going through today. We are providing free resources here, so don't do anything that you wouldn't do in your own AWS account or run up a huge bill doing anything strange. So yeah, after agreeing to the terms and conditions, we can join the event. And then this is going to take us to our event dashboard here. You can see how long we have access to the accounts. And in order to log into the console, what we're going to want to do is enter the sidebar menu. For you, if you've got this full screened, it may just be on the left-hand side, but for me, it was in that little hamburger menu. And then there's an Open the AWS Console button. We're going to go ahead and click that. Take a moment for us to get logged in here. All right. So now that we are into our AWS console, we're going to want to go to Cloud9. This is the spot we're going to be doing the majority of our work today. Cloud9 is a cloud-based IDE that we offer on AWS. It includes a code editor, debugger, terminal, and also has some other pretty cool features to help you develop efficiently in the cloud. So in this search bar, we're going to search for Cloud9. And then go ahead and select the Cloud9 button here. As part of setting up this account, we've already created a Cloud9 instance for you to use. This is the IDE that runs on an EC2 instance. And it's pretty nice because you can work on projects from your home, office, or wherever you have an internet connection. You've got a consistent development experience each time. And you can spin up different sizes of Cloud9 instance as well, depending on your project's performance needs, so different operating systems and whatnot. If you click into this workshop workspace instance here, you can get some details on our environment. Today we're going to be using a T3 small because all we're using this for is accessing that Kubernetes cluster, Amazon Linux 2. And up here at the top of this screen, we have the Open in Cloud9 button. And we're going to want to select that. And definitely let me know in the chat if I'm going a little bit too quick, or if the pacing is just fine. If I could get a +3 if I'm going a little bit too fast, I'll keep an eye on that and kind of make sure that we can slow down if necessary. All right. So now that I have Cloud9 open, the first thing I do is a little bit of housekeeping here. What you're going to see is a welcome screen here in the middle. Since we don't need that today, I'm going to go ahead and close that out with the X here at the top of this bar. And then it's opened up a terminal for us to interact with here on the bottom. And what you can do is go ahead and click and drag this up to where that welcome screen bar was to give ourselves a little bit more room to work. And then since there's nothing else down here that we really need, we can pick this X here in the corner to go ahead and close that out so that we've got a little bit more space. All right, so now that we are all set up with our account and we're in our IDE with our terminal, now we can start interacting with our cluster a little bit in the form of deploying our EKS ingress controller and our EBS CSI driver. So let me go ahead and grab I'm going to be sharing in the chat the starting point for our instructions. And this is going to be the spot where we have all of these commands that you can copy over into your console to run this alongside. And in this navigation bar, if you're on a different page within this workshop, where you'll go is into the Launch EKS menu, and then the Deploy Ingress Controller page. So the first thing that we'll be doing, sorry, see somebody is missing audio. Can other folks hear it okay? And I'll drop the link to that page in the chat there again so that folks can grab that. All right. So the first thing that we're going to be doing is exporting the cluster name into a variable using this command here. Cool thing about Cloud9 is that you can apply roles and permissions directly to the instance that you're working with. So our instance already has the permissions for running commands in AWS all set up. So use the copy button up here in the corner and then paste it here into our console. Next, we're going to check whether our load balancer controller version has been set. Now, because we use this kind of cluster setup for different types of workshops, what I'd expect for you to see is that it has not been set. So we're going to want to run this command here to export a load balancer controller version into our bash profile there. So we can copy that command, paste it into the console, and then hit enter. And now that that's completed, the next thing that we're going to do is check to see whether Helm is installed. Oh, keeps hopping me up to the top there. It should be installed in your environment. Please drop something in the chat if you receive a message different than a version number here for this command, and we can help you troubleshoot. But we also have in this info box here instructions for installing Helm if it does not give you that version number there. But perfect. It should be installed for all of you. And for the participant that was asking how to get to the left page with the commands, in the chat, if you scroll up just a little bit, we do have the link to this workshop. And for one of the co-presenters, can we add that to a sticky at the top just so that we can kind of make sure that they've got access to that? All right. So the next step here is going to be creating an OIDC provider so that when we're running the rest of these commands, we have the correct permissions on our clusters to do so. So we'll grab this command here for EKS control utils, associate OIDC provider, paste that into our console. And then that'll go ahead and create that ID provider that we need in our AWS account. Next thing we're going to need to do is create an AIM policy for that, or like for our load balancer controller to use. This command here is going to download a JSON file to our Cloud9 instance. And then also it'll create a policy using that file. So if we go ahead and copy this, paste it into our console, and then hit enter to send that second command, it'll go ahead and create that that role for, or that policy for us. And then if we open up our file explorer here on the left-hand side, these little kind of file indicators, you can actually see where we've downloaded that policy file. And a double click into that will show you what policy we are using for this. That's a little bit beyond the scope of this workshop. I just wanted to kind of point it out to you if you were curious. So we can go ahead and close this JSON file. All right, now that we have that policy created, we're going to go ahead and create the AIM role and service count for our cluster. And you'll see that down here, we have our kind of AIM load balancer controller policy as a part of that command. You can paste that into our console and hit run. And that'll take a couple of seconds to go ahead and create. At this point, does anybody have any questions, or please let me know in the chat if our pacing is a little bit off. If it could go a little bit faster, a little bit slower, please let me know, and I can kind of make adjustments as we go. All right, so that has finished creating our role and service count. And then once that completes for you, the next thing we're going to do is install the target group binding custom resource definition here. And then use the command to get that CRD. And after some of these, it'll run that first command, but you may have to hit enter to kind of get it to run that second piece. Just as a little quirk of the workshop here. All right, so once that has completed, we can use this final command on this page here to add the Helm repository for EKS and deploy our load balancer controller with the Helm chart. So what we've done here on this page is get all of those permissions together for our load balancer controller and then go ahead and actually deploy it to our cluster there. And you should see deployment AWS load balancer controller successfully rolled out. So once everybody has seen that message, next we're going to select this kind of over arrow to go on to the next page and deploy that EBS CSI driver. And because we got that ID or OICD provider set up, this one's going to be a little bit easier. We're just going to create that role and service account, this time using a managed policy called Amazon EBS CSI driver, or driver policy. and then we can deploy it with one more command. That may take a moment to deploy as well. Because with each of these kind of larger commands that we're running, it's going to be deploying a CloudFormation stack in the background. Since we'll have a moment to kind of wait, does anybody have any questions so far? All right. And just while we're kind of waiting for folks to catch up, a little bit of context. This EBS CSI driver is going to be the Elastic Block Store Container Storage Interface driver. That just means that it's going to allow our cluster to kind of manage those EBS volumes that are in use.
So Mike, just one question real quick from the participant. So what is the event access code and how long will this lab environment be available to the participant? Because someone may want to access and do the workshop later on their own base.
So the event access, we have the links that are sticky on the, it looks like we may have pulled those account access links down. But we have some quick kind of account access URLs that you can go to. And then within that, it'll give you the one-time password option that you'll select to gain access to your temporary AWS account. And I can go ahead and drop some, let me grab those again and just put them into the chat. So there's one of our URLs for accessing the free AWS accounts for this. And here's that other one. And either of these will work for getting you access to the same infrastructure. Just in order to have the correct number of accounts for today, we needed to set it up on a couple of different links there. So if one of them has already used all of the accounts, go ahead and try that other one. It'll get you the same hardware that you need. All right. And with that EBS CSI driver all set up, that kind of has created a good base for us to run the rest of our Kubecost specific portion of the workshop. So I'm going to hand it back over to Lynn and Chris.
Thank you so much, Mike. So wait for me 1 minute. I'm going to share my screen real quick. All right then. So just want to check, can everyone see my screen now? Just put +1 when you see my screen sharing. Cool. Someone seeing my screen right now. So thank you, Mike, for excellent presentation and introduction and walk everyone through how to set up the environment for our workshop today. So you can see on the screen is I'm going to walk you through the deploying accessing Kubecost section. Basically, you will understand how to install Kubecost quickly with the helm chart and how to expose Kubecost outside of the Amazon EKS cluster so you can access it or share it with the other team to access. And before we get into the demo, I would like to give you the quick overview about Kubecost. Kubecost is the software that provides real-time cost visibility and insight for teams using Kubernetes and helping you continuously monitor the cost of the container workloads at the granular level. Kubecost can give you the visibility into the cost of your Kubernetes application, starting from the container level on the way down to the starting from the cluster level and going all the way down to the container level. And with those information, you can have the appropriate action to optimize your cost or reassign the necessary resources for your Kubernetes application to optimize the cost. And Kubecost also give you some recommendation as well, so you can take action. Chris going to help you to understand that in the next section after the installation and expose Kubecost in the next couple of minutes. And what you see on the screen right now is the reference architecture of how Kubecost work with Amazon EKS today. We have so many integration with AWS team today, but in our workshop, I would like to walk you through the major way to deploy Kubecost on Amazon EKS cluster. So technically, when you install Kubecost on the Amazon EKS cluster, you can use the Helm chart that being stored on the Amazon ESA public gallery and the container image stored on the Amazon ESA public gallery that's being continuously being scanned and verified by the AWS team and the Kubecost team. So when Kubecost is on your Amazon EKS cluster, there are two major components that are going to help to track, monitor, and optimize the cost inside your Amazon EKS cluster. The first part is the Kubecost part, or the cost analyzer part that have two main components running inside. One is the cost model. You can think about it as a backend of Kubecost that's going to handle the cost allocation calculation and receive the request from the front end, which will act as a dashboard for you to show the cost report for you and handle any API call going to the Kubecost front end. So when the Kubecost start is going to fetch the AWS public pricing data going to the using the on-demand API provided by AWS for the cost calculation, and combine with the second component, which is the metric from the second component, which is the Prometheus pod that will collect the metric inside your Amazon EKS cluster and store the metric in its own time series database. Combines the data together, Kubecost will be able to calculate the cost of your content application at the granular level. And optionally, if you give the Kubecost the read permission to AWS cost and usage report data, Kubecost will be able to reconcile on of the calculation cost and accurate provide you the most accurate cost data that will reflect any saving or any discount that may apply to your specific AWS account or AWS organization. And once Kubecost is on your Amazon EKS cluster, you can explore it in different way that we will go through as part of the workshop today. All right then, so that is about Kubecost architecture with Amazon EKS. So the first step you need to do is, so I have my Cloud9 up and running already. So the first thing you need to do is to install the Kubecost with a single command, single ham install command. That's showing on the screen right now. So what you see is we are going to use the Kubecost version 1.103.2, but you can also find the latest one or the newest one, newest version on the link in the workshop right here, on the ECI public gallery. So we're going to copy this command and install Kubecost. Just copy and paste it. There we go. Now it's going to fetch all of the Hemjack and the content images from um, Amazon ECI public gallery and deploy it on your Amazon EKS cluster. You will see some information on how to quickly export Kubecost to your local environment or workspace in order to access it. So next, let's check the status of the deployment. The deployment should take less than 5 minutes to be up and running, and you can access the Kubecost. In my experience, it's usually just take like 2-3 minutes for the Amazon EKS cluster. I will stop while waiting for it. I will stop here a little bit to check if there are any questions. And if you have any question, feel free to put it into our Q&A or put it in the chat box. I'm happy to answer. My co-presenter can help with the answer as well.
So we
All
do
right.
have one
Yeah.
question here in our Q&A that got another kind of upvote, so it may be good to address. I wanted to ask, is it possible to drill down to the costs of pod and workloads by tag?
By the tag of the AWS, yes, it is possible. And you can also aggregate the cost by label as well. It should be covered in the next section using Kubecost, and Chris can help you to understand how it works with Kubecost today and share more details around that. All right, so Kubecost should be able to be up and running right now. So you can see the status right now. All of the components being deployed with Kubecost as part of the Kubecost deployment is now up and running. I will clear the screen a little bit so you can be easier to follow. So next, right after you install the Kubecost, you can quickly do the port forwarding to your local workplace or your local environment in order to check if it's actually up and running or not. So we can use the port forward command here to forward it to the port 8080 of the Cloud9 workspace. All right, now it's ready to handle the connection from the Cloud9 workspace. So technically, you can find the detailed instruction in the step 3 here, but I will walk you through real quick. You can click on Tools, go into the Review, and click on the Preview Running Application. So I will move it here so you can easier to see. So you can see that the Kubecost UI is now up and running. Kubecost still need a little bit like extra 10-15 minutes to fully collect all of the metric inside your Amazon EKS cluster and give you the full information. So you may see some, $0 and some expected error here, but no worry about that. And Chris going to walk you through the this UI in the next couple of minutes real quick. And what you can check here is that Kubecost is fully up and running and collecting the data. We will close it for now and save it for later. All right, let me clear my screen a little bit and easier for you to see. All right then. So you're able to install the Kubecost and access the Kubecost UI real quick using the port forwarding. However, in order to expose the Kubecost or Kubernetes application outside Amazon EKS cluster, so you can access it later, there are many different ways that you can do and to share the access with your team as well. So in this workshop, we are going to use the AWS load balancer controller in order to export Kubecost using the AWS application load balancer, so you can access the endpoint easier outside of the Amazon EKS cluster. So what you can see right now is just outline what we are going to do. So Kubecost, we already have it installed. Next, we will install the AWS load balancer controller and deploy an ingress object, basically a configuration to tell AWS load balancer how to export Kubecost to an application load balancers, and then handle the request from the customer or from the client and redirect it back to the Kubecost backend. All right, so in order to do that, it's really easy. What you see on the screen right now is just a script that with the configuration of the ingress, that's going to tell basically using the AOB as a controller, as an ingress controller, and we are going to expose this for the demo purpose. We're going to expose the endpoint. This is the internet facing or public facing one that everyone can access it. And this the rule here, it will tell how to handle requests going to that endpoint and how it can find the service, Kubecost service running in the backend. Right, let's copy the command and paste it here. Just press enter. It should take just like few seconds to create the ingress. All right, next, It will take like a couple of minutes in order to fully create the AWS application load balancers for you and allow you to access to the endpoint. You can run this command from the workshop. It will give you the uh, URL that you can use, or basically the AWS application load balancer endpoint that you can use to access to. So it might take a couple of minutes, like I mentioned, around 5 minutes from my last test in order to access to it. So you may need some time to access it. And just want to show you, if you click here, if you use access to the endpoint, you may see this message appear. So you expect it. So just give it a couple of minutes. All right, while waiting for it to be available, just want to check real quick. If you have any question, anything that you want me to answer, please feel free to put it into the chat box. Oh, make the left side graphic lecture? Absolutely. Let's try again. It could take a couple of minutes. We can access to it later. So in the interest of time, I will hand it over to Chris. So Chris can walk you through the Kubecost functionality and show you a working environment that has the data that you can help you to understand better about the Kubecost. I will hand it over to you, Chris.
All righty. Thank you, Lynn. All right. Let's see. Share. All right. Go ahead and give me a +1 or a thumbs up in the chat if you can see everything here on my screen. So, like your favorite cooking show, I'm going to switch over to a demo environment that has lots of data in it that we can see here. So, primarily today, what we're going to focus on is the visibility side of things. So, what is actually going on within my cluster, driving the whole way down to the container level and the costs that are associated with it. So I've hit the overview page. You can see my, the clusters I'm monitoring, the costs that we're saving over the last 7 days, our total costs, savings, and the efficiencies that have been identified. So we're going to go into the monitor and then go to allocations. And what we're going to do is we're going to see what we're seeing for the last 7 days. The allocations is really our kind of our chargeback and showback and visibility page. It's the primary driver for the FinOps models that you use within your environment. So we've aggregated over the last 7 days. We can go to 30 days if we'd like, but we'll keep it simple with the last 7 days. We have the ability to aggregate about 15 to 20 different Kubernetes concepts. In this case, we're going to keep it very simple for namespaces, but you can even go even further as to with labeling if you're labeling properly within your environment. Here under the Edit tab, we have the ability to break the chart out in a couple different ways, change our cost metric, the ability to do filters. And I know there was a question about applying filters and how you want to aggregate by a namespace. So I've set one up here that's for this cost center equals 13. It's a label that we've applied on a namespace. And as you can see, it will come back and it says, hey, the Acme Fitness namespace has that label. So we filtered out and only reviewing the information that is related with that. We also have the ability to take and define these shared resources. So in this case, let's say Kubecost 2, and this is a namespace. What it's going to do is it's going to remove it from the chart below, and it's going to distribute these costs. So of all this data we're bringing back the CPU costs, GPU costs, the RAM costs, the PV, aka the underlying storage cost, network costs, load balancers, shared, which is what I just demonstrated when we said Kubecost 2 as the shared cost, and then the efficiency, which is the max for CPU and RAM request, and how much of those resources you're using that you've requested versus what is sitting idle, and then the total costs that are associated with everything. And you can see all of that broken out here within the chart, and then the breakdown within the chart of those costs that are associated with it. So let's dig into the Kubecost namespace here. So there's two different ways to view the data. So we're going to first click inspect, and it's going to bring up a page here that will load the data that's going to say, hey, here's just the general cost overview of what you're seeing for this namespace, potentially savings that we've identified, the controllers that are running within the environment, their efficiency scores, their costs that are associated with it. And then it gets down into the daemon sets and their, if they're hitting OM evictions and whatnot, or if they're hitting throttles. In addition, we have integrated this environment with our AWS cost and usage report, aka our bill, by an Athena query. So this way we're bringing back these additional service costs that we've associated with this namespace. So we're saying, hey, we have some AWS Lambda functions that we're using. We've applied the label to this namespace, and here's the associated costs that we're seeing with it. Same with their network costs over here. So we've gone ahead and deployed the associated configurations needed for networking, and we're bringing back these costs that are associated with different services within AWS for this namespace. So if we go back to our page here and then click on Kubecost, this is where we kind of start drilling down into the Kubernetes layer cake itself. So now you can see we're at the deployment set. Let's go ahead and drill into the cost analyzer pod. We're going to go further in. You can see now here's the associated cost for it. And then we can go the whole way down and actually see the individual resources that are being used, the hourly rate that's associated with it, the adjustment column, which is if we are receiving any discounts from our cloud provider via the cloud bill, and then the costs that are associated with it. You also have the ability to view this data in Grafana if you have turned on the optional Grafana data. In addition, there's also the ability to see your assets, your clusters, and your cloud costs. But for the purpose and time for today, we're just going to stick with viewing the visibility. Now, Kubecost is a UI first product or an API first product, but everything we do is accessible via the API. So what we have shown you today on the UI side, we're now going to show on the API side. So everybody should be seeing a terminal now. So I've put in my first command that we're going to pull here. So I had previously said, we're viewing a window of 7 days. We're now going to view it of a window of 3 days. We're still going to aggregate via the namespace. We're going to bring back the shared idle costs and saying we're not going to do that this time, and we're not going to accumulate our results. We go ahead and hit return, and this data is going to come back via JSON. You also have the ability to split it out via CSV if you'd like to. So go ahead and clear this. So the next command that we're going to run against the allocation API, so that was everything we had just seen on the UI side of things. We're now going to shorten the window to 1 day. We're now going to aggregate via namespace and deployments, but we're going to change the accumulate to true. This will come back here in a second, bringing back all the same. So you can see all the pods that we're using here, the provider ID, the underlying infrastructure that it's sitting on, GPU adjusted costs, any costs that are associated with that query and that data. So the next query that we're going to do is going to be still a 1 day window. We're still going to aggregate via namespace and deployments, and we're still going to say true. And that's going to bring back some more of that data. But looking at the assets queries that we can do here, running against the assets. So the assets is the underlying infrastructure that we want to see that we're running on. So for EKS, this is the underlying Kubernetes infrastructure that you can see under monitor and on the asset side of the page on the left-hand side of what is the cost of the infrastructure that I'm running on, the instances, and everything that, Amazon will manage for you with the EKS offering. This will bring that back in that query for your total costs. Now with that, I will send it back over to Lynn to talk about Amazon Managed Prometheus.
Thank you so much, Chris. So let me share my screen again. All right then. So please +1 if you can see my screen. I just make things look bigger a little bit to just for you to easier to see. And I also make my Cloud9 bigger again because I think it's a little bit hard to see on different type of screen. All right then. So as you just see from Chris on how Kubecost can help you to get the visibility into the cost and how Kubecost and how you can retrieve that data programmatically using the API. I also would like to introduce to you another integration that Kubecost has with the AWS team. That's called the integration with the AWS Managed Prometheus. So Amazon Managed Prometheus is a managed Prometheus compatible monitoring service that enable the customer to easily monitor the Kubernetes cost at scale. So what does it mean is that, let me open the diagram architecture. As you can see right now, it is similar to the previous architecture diagram that I show you when Kubecost being installed on the Amazon EKS cluster. And I mentioned that the Kubernetes cluster metric or Amazon EKS cluster metrics is being stored inside a Prometheus time series database. And as your business grow, the infrastructure may grow and your Amazon EKS cluster may grow. And over time, the data stored inside the Prometheus time series database growing bigger and bigger and bigger. And eventually, it's really hard to maintain and scale, which is one of the pain point of the Prometheus. However, so by that, so to recognize that pain point and to solve that pain point for the customer, Kubecost with AWS Amazon Managed Service for Prometheus team have the integration that with Kubecost and I would call it AMB workspace or the Amazon Managed Prometheus workspace. Kubecost will now store the metric inside the Amazon Managed Prometheus workspace. And the Prometheus here only act as a metric collector to collect the metric and temporarily store it for, like, for example, 50 days, 30 days. And all of the metrics will be replied to the AMB workspace for the long-term metric retention. Kubecost will query the metric directly from the AMB workspace. So you don't need to worry about the scaling the Prometheus database or maintain it or back it up. All of that task will be handled by the Amazon Managed Prometheus. And Kubecost can query the data back, for the long-term metric report, for example. All right. So in order to integrate Kubecost with AMB, I put together an instruction that you can access, that you can see in the workshop, and you can also access to it later as well. Just want to answer some question that I see in the chat. So first, what you need to do is you need to create an AMB workspace or Amazon Managed for Prometheus workspace with a simple command like this. All right, just copy and paste. It will create a workspace for you. It should take like just a couple of seconds to provision a new workspace for you. It's really, really quick. And then next, what you need to do is to capture this workspace ID. You can run this command. This will going to query the workspace ID and show you the workspace ID that we will use for the integration with the Kubecost later. All right, next. We will set a couple of the environment variable that you can use for the Kubecost integration. So I just want to explain to it real quick. What we need to do is what we need to have is the cluster name. So Kubecost basically can send the metric, specific metric for your Amazon EKS cluster to the AMB workspace. And you need to specify the remote bright URL, basically the endpoint that Kubecost going to send the metric to your AMB workspace, and the query URL, basically the endpoint that Kubecost will use to query the data for the cost allocation calculation. All right, so just copy the environment variable here, click enter. Let me clear the screen a little bit for you to easier to see. All right, next, we have prepared all the environment already. So next, what we're going to do is to create an IRSA IAM role for service account. Technically, with this, it will give you, this will give Kubecost installation the permission to read and write data or interact with the AWS services, in this case, which is the AMB workspace. So there are two service accounts that we need to create. One is the service account for the cost analyzer or the Kubecost part, right? So it will take probably a couple of seconds and maybe just 2 minutes max to finish. And the second one we are going to do is we are going to create is the one for the Prometheus server. It needs the permission to provide the metric to the AMP workspace. So we also need to grant the permission to the Prometheus server that go with the Kubecost as well. All right, the first one just completed successfully. Now let's create an ISA or the service account for Prometheus. In the meantime, I will check the chat box just in case if we have any question. So again, it just take a couple of minutes, but I just would like to highlight a few things. If you in your environment, you may it's probably be shared by multiple team, multiple people. So you need to make the you may need to make the policies, or the IAM role name unique to your environment, because the IAM role name need to be unique. So just a quick note here. All right, then the Prometheus ISA or service account has been created and associated with and have the right permission in order to work with the Amazon managed Prometheus. So the last step here is we're going to upgrade our Kubecost deployment, because we already deployed the Kubecost. So we just need to upgrade or update that deployment with the extra information to tell Kubecost, hey, now let's read the data from Amazon Managed Prometheus and tell the Prometheus instance that let's provide the metric to the Amazon Managed Prometheus. So you can do this with this single ham installation command. There are a couple of configuration called custom values file that has been decided. This is the one that being hosted by Kubecost and managed by Kubecost. So I put it here for you to easier to install and quickly install Kubecost with Amazon Managed Prometheus. All right, so just run this command. It's going to check and pull the image ham jack from the Amazon ESA repository again, and then apply the new configuration to your current deployment. It could take like 2-3 minutes again in order to apply the new configuration. And one last step you need to do is to restart or run out the deployment of the Prometheus server in order for it to take the new configuration, because what's going to change in the background is the config map configuration, and we may need to restart the deployment so it can see the new configuration and apply it. All right, so it will take like a couple of minutes in order to finish the integration. And once you have it up and running, it just appear normally, just like what we see with the Kubecost running on, Kubecost running with the bundle Prometheus and start the data locally. However, you can check it real quick by running. So for example, this is the environment that I already have, and that's going to work with the Amazon Managed Prometheus, integrate with Amazon Managed Prometheus. You can check this by running this command, status. So you just need to hit the model status endpoint. It will tell you this is the expected error. So don't worry, because this cannot basically connect with the Prometheus, the local Prometheus, but it will tell you that it's actually using a proxies as an endpoint, so Kubecost can query the data from the Amazon Managed Prometheus. So this is the expected message, and you can see it's already connect with the preserved proxies via an Amazon Managed Prometheus ID that I already created. So get back to the UI. So it just appear as just the normal one, but now the all other data, the matrix has been stored on the Amazon Managed Prometheus instance. And you can check the setting here. We just zoom it out a little bit so you can see it easier. So just going all the way down so you can see the Prometheus status. Everything looks good now. All right, with that, the workshop should be done now. And please let us know if we are going too fast. And with the remaining time, please feel free to let us know if you run into any issues or if you have any extra question or anything that you would like us to show you in the demo. I will check the Q&A real quick to make sure that I will cover all of the questions. So there is a question that how can we calculate cost of POS from different value streams in a corporation that deploy containers in a common clusters using tags or label? So this is the great question. So let's get back to the allocation view where you can find the cost associated with each Kubernetes objects or Kubernetes application running inside your Kubernetes cluster. Like Chris already mentioned, Kubecost will be able to aggregate the cost by different Kubernetes objects, starting from cluster level on the way down to container level. And you see here is by default, we aggregate the cost by the container context. Oh, sorry, namespace context. Sorry about that. By the namespace context, and you can see the cost associated with each namespace breakdown by different category. And in the Kubecost UI, you can also change the context here by, you can aggregate the cost by different Kubernetes contexts like cluster or like container. So the question here is, if you have many container that being deployed in different namespace, but you would like to get the visibility on that, you can also aggregate the cost by the label as well. So you can see, you can put the label name here or the label key here. I will put it on the most common, the label that being used by the Kubernetes application, which is the app APP. So if you add a label here or you have the container deployed with the same label and you would like to track it, the cost associated with the container with the same label, you can aggregate the cost by the label, and Kubecost will be able to give you the visibility into a report for all of the container or like the workload that has that type label and the cost associated with that. Hope it helped to answer your question. And if you have any follow-up question, further question, feel free to let me know in the chat or in the Q&A.
And Lynn, if you could go over to the instructions real quick, I might plug the other kind of workshops that we have too, if we've got a second.
Yeah, sure.
On the left side, below our kind of navigation there in the more section, you can see a number of different links for kind of other workshops and learning content that we have available. One that I would draw your attention to in particular is the EKS workshop. We've just retooled, it's the fourth one down there. We've just retooled that entire workshop, so it's more streamlined and more concise. You can do specific kind of sections to get upskilled on certain topics, and it really is a super valuable resource. So if you've got something specific about EKS that you're interested in learning, I'd encourage you to take a look at that.
Yep, thank you, Mike. And in this section, you can also find a lot of information, different workshop information about provided by AWS, as well as the information about Kubecost product and the Kubecost collaboration uh, with AWS team as well. So you can find information about how to integrate Kubecost with the AWS cloud cloud building, like the AWS CUR cost and user report. And you can also have a link to access to our record a couple months ago with the container from the cloud team to explain more about the Kubecost functionality and how Kubecost work with the Amazon EKS cluster. And you can find most of the information about Kubecost and Amazon EKS in this link as well, Kubecost documentation for Amazon EKS. And if you're interested in, if you have further information or interested in contact us or submit any question for Kubecost, you can click on the latest link here, learn more about Kubecost and AWS collaboration, where you can find information about the AWS and Kubecost collaboration, and you can put any question, any information, inquiry about Kubecost in the box here. And one of our member of our team of Kubecost will be able to help you with the question or reach out to you if you would like to discuss further about Kubecost.
Well, then I think we've got a couple more questions in the Q&A that are new as well for Kubecost specific items.
Okay, let me check in the new. How I can have, okay, sorry. So let me go from the start. Wanted to ask a question that may be covered coming up. Is it possible to drill down to cost a part of work loss by tag?
Oh, yeah, that one we went through.
We went through already,
sure.
okay.
Yep.
So the next one, when installing Kubecost via console add-on, instead of the Hammer, does it have a difference in capability and version? Great question. So when you install the EKS add-on via the Amazon EKS console, it's used the same resources that we have inside the Hammer. So it's had the same functionality and the capability that provide to the Amazon EKS cluster. However, because of how Amazon EKS add-on work, the customization and configuration may be different than the Hamjack one that we have. And you can find a lot of information about how to configure Kubecost, customize Kubecost installation with Hamjack, about the EKS add-on that we are still working with Amazon EKS team to improve that. But to answer your question, in short, yes, they have the same capabilities for the Amazon EKS user and specifically for Amazon EKS user. How I can have a dashboard with filters to see the cost by environments, categorized by business unit or namespace. So I would love to learn more about what do you mean by the environments here, like per namespace. For example, let me open the Kubecost UI real quick so I can explain further. And please feel free to let me know if that answered your question or not. If not, please feel free to submit another question. So about your question, like I said, Kubecost can aggregate the cost by different Kubernetes contexts, and not only the single Kubernetes context, but you can also combine the you can have the multiple aggregation as well. For example, if you would like to see the cost by cluster and it's breakdown by the namespace or by the business unit like department or something, you can also do that with the multiple aggregation. So when you select cluster and namespace, Kubecost going to generate the new report for you that will break down the cost by namespace, multiple namespace, and the cost associated with each. Oh, sorry, the cost by each cluster and the namespace inside each cluster. As you can see on the screen right now, I just aggregate the cost by cluster and namespace. So it depends on how you organize or your department organize the workload inside your Amazon EKS cluster. You can select different multiple aggregation to aggregate the cost or generate the report for your purpose. Hope that help to answer your question. If not, please feel free to submit another question, and happy to explain further about that. All right, cool. So let me check. There's a new question. staging, development, and production. So yes, so I assume the staging, development, production here is running on different cluster. For example, if you tag each different cluster in, for example, environment, if you have the associate tag for each environment here, you can aggregate the cost by different environment as well for each cluster. Chris, for that, do you have anything to add here?
Yeah, so for that, I would say go ahead and do a single aggregation, Lynn, based on cluster. So I'm just going to make the assumption that staging, development, and production are separate clusters. So just click cluster there at the top. Yeah.
Yep.
So you can see that we have two clusters in this environment here, and you can see the cost broken out by two different clusters. But say you want to see a namespace that's broken out. So if you go ahead and select cluster, Lynn, the aggregation, sorry.
Yep.
And then do multi-cluster or multi-aggregation, do cluster and namespace. And then hit edit and just do a filter on, say, Kubecost for the namespace.
And just add it.
Yeah. So we have the ability to take it even further and say, okay, what is the cost of running the single application across multiple clusters? And in this case, we define the application as a namespace. We can then see, here's that cost of running it either in stage development or different regions and so on and so forth. If there's any more detail you want on that, please feel free to reach out to us. Like Lynn showed earlier, the contact us page, or drop some more here in the Q&A.
Thank you, Chris.
I think we've had a few questions come through in the main chat here as well.
Yeah, Kubecost installed from console add-ons come with an older version. How can I get the latest version? Good question, because of different process in order to update the Kubecost integration with AWS. We are trying to make it as fast as we can right now, but EKS are only quite new, so the process to update is not streamlined yet. I'm still working with the AWS team in order to make it faster. You should be able to see the 1.102 available for you right now, and I expect 1.103 should be available soon for you, maybe next week or next 2 weeks. All right, so just want to check another question. Is Kubecost high availability? Who is responsible for its infrastructure? Yes, we do. And there are different ways that you can configure Kubecost to make it high available. And in terms of who manages, we have to tie up the deployment. And in this workshop, you just learn about the self-hosted or the server-side deployment of the Kubecost. And the entire Kubecost infrastructure installation will be managed by your team on your own environment. Kubecost doesn't send out any information. All the information, all data stay inside your environment. So will have the full control on the data and the installation of the Kubecost. And we just launched the new offering, which is the Kubecost Cloud. Basically, is a SaaS model where you will install a small agent, Kubecost agent inside your cluster. It's going to collect the metric and send it into our control plane. It is a SaaS model, and we will help you to manage the data, manage the infrastructure, and show you the cost of your environment in an endpoint that you can access. So feel free to reach out to us if you would like to learn more about SaaS offering as well. So I see question around the purchasing. So it's under the govern. You can find under the govern and the purchase here. For the demo purpose, we have not set the purchase yet for the demo, but you can play around with it on your own as well. If you click on setting and enable the free trial, we offer the free trial, 30-day free trial for another feature, another paid feature. So to quick demo, you can click on new purchase here, and you can set the budget like Kubecost. And here you can set up like a threshold, like how much like money in terms of like dollars. If a purchase of us, for example, like a namespace go over $50 a week, is going to send you an it will display here on the Kubecost UI. And for example, I can put it like Kubecost, and I can send, set a new action like is it reached like 100%, it's going to send an email, or if you're using Slack or Microsoft Teams, it can send the information via the Slack webhook and Microsoft Teams webhook as well. So you can show it on your instant messaging application. And when you save it, Kubecost will monitor that and just tell you like if it exists the purchase or not. Let me try to save it here. So you can see that Kubecost already used like $3 in, $50 purchase. So just a quick demo about purchase here. And please feel free to add your comment if you would like to see it in our workshop, and we can update more contents later. And the link to the workshop is publicly available and will be available for you to run it on your own base later. And we will continuously update the new contents as we have the new integration with the AWS team.
All right, Lynn, are we wrapping up?
Yeah, so that is what I would like to show you about the Kubecost collaboration with Amazon EKS team. So feel free to reach out to us if you have any further question or any question pop up later. You can find the information again in the link on the workshop page. Learn more about Kubecost and AWS collaboration. Thank you everyone for joining today.
Yeah, thanks everyone for coming. And just remember, you do have the access to those accounts for another day or two here, so you can continue to play around with it and kind of look at the features. And yeah, thanks again.
All right, I want to thank all of our speakers today, Lynn, Chris, Mike, for taking the time to join the discussion and share all of your expertise with us and give us that great walkthrough. Just a quick reminder that today's program is recorded. So following this panel, you'll receive an email to access this on demand. You can also go to devops.com or cloudnative.com/webinars, look in the on-demand section where you can find it as well. I did mention at the beginning of this program that we would be giving away 4 $25 Amazon gift cards. So our winners are Gabby S., Brittany H., Amelia C., and Ionis S. Congratulations to the 4 of you. Please keep an eye out on your inbox and also your spam folder. Sometimes they do show up there. Thank you for everyone who attended with us and stayed with us for the entirety of the workshop. Guys, do you have any last remarks that you want to say? Or are we all good to go? All right, sounds like we are all set. I want to thank AWS and Kubecost again for sponsoring today's workshop. I also want to thank you again for being here. Please take a moment to fill out the quick survey that we've got after this closes out. Let us know how we did. Let us know any of your comments. And we hope to see you on more of our upcoming TechStrong learning experiences. Thank you and have a great day.